So now we're going to get on with building section 411 and 412, which I've called various resistors and drivers. And basically what we're going to do here is we're going to install the 270 kilo ohm resistors. So that's R8 to R11. And they're the ballast resistors for the neons here. Then we're going to install the 6 270 ohm resistors, which are R12 to R14 and R17 to R19. And their task is to limit the current to the LEDs and for the speaker circuit, where to limit the drive to that. Then we're going to install R16, which is a pull-up resistor for the temperature sensor, and R20, a 1 kilo ohm resistor, which I really can't fathom out the use for, other than it might be to discharge the low voltage circuit when you turn the clock off. But it seems a weird thing to want to do. So let me just find out which one of these is which, because I have to say the markings on these blue resistors is really not at all clear. Let me put this in the picture so you can see it. So this one here is 10 kilo ohms, so that's R16, and R20 should be 1 kilo ohm here. So yep, that's good enough for me. Alright, so then we're also going to look at doing the supercapacitor circuit, which I've got the components here for. That's C6 and C7. But let's do one bit at a time. So first of all, section 411. So we're going to do R8 to R11. So R8, R9, R10, R11, close to the neons there. And we're just going to form the leads by bending them and counting in reverse order. Let's not mix those, goes up. R11. R10. I really should get a leg bender. I have a wish to have a leg bender now. I'm sick of bending these legs by hand. I want a tool to do it. That would make my life much better if I had a leg bendy tool. Okay, that looks good. They seem to be more or less in the right place. Now let's solder them up using the usual trick of one side at a time. Oh, look at that. Look at them running around everywhere. Stupid resistors. Stupid me for not nailing them down. I really do need a leg bender. Anyone got a leg bender out there? I need a leg bender. Otherwise I'm going to end up pulling it through with brute force. Which of course works, because brute force always works. But it's not really recommended. Brute force and electronics doesn't usually mix well. Brute force and anything doesn't usually mix very well. Okay, let's have a bit of a tidy up there. Trim off. Trim off. I joined those two together by sloppy soldering. I'll go and unjoin them in a second. Those are R8 to R11, now R12 to R14, R17 to R19. Well, I can see R17 to R19 straight away, so I'll go and stuff those in first of all. 19. And 17. First, I just want to make sure that I'm not mixing up that 1K resistor with anything else. That's the 10K resistor. And that's the 1K resistor. Let me just check that again. If I put the wrong thing in the wrong place, that's going to be embarrassing and stupid. So this should be a 1K resistor. The trouble is with these blue, put it on. Yes, that's the 1K resistor. That's the 10K resistor. You get over there, out of the way, chaps. Okay, let's put these guys in first. Learning from our past mistakes, let's tape these guys down a bit. Stop them running around quite so much. Couldn't we just have one integrated circuit to do all this nonsense? This is just hard work for no reason. So other parts of the clock are made so that things are really easy. And this part, I have to say, is made to be unnecessarily boring. It seems to be really a lot of hard work compared to things like the HV circuit, which was so easy, or the resistor networks, which were also dead easy. Now here I'm fiddling around with silly little resistors for things that I don't even really care about. I don't really care very much about the speaker. Okay, that's just me. Okay, that's section 411 done. No tests to be done here, so we'll get straight on to Q1, which will be there. And that has to be the MPSA 42, which is not that one, which is not that one, which is that one. And you have to make the flat side match up, of course, with the flat side on the PCB. So that's the driver for the little speaker which will go there, presumably on the bottom, indeed. These guys here are the drivers for the LEDs, so the RGB LEDs. One's for the red channel, one's for the green channel, and one's for the blue channel. So in my experience, the 2N7000s need to be treated with care, especially when dealing with the blue channel. It doesn't take much current to light up a blue LED, and even the slightest leakage on these causes the blue channel to come on and stay on and not go off again. So I'm trying to not spend much time on these. I'm trying to go through them fast and not stress the components. I also have the idea, wrongly or rightly, that the 2N7000s are static sensitive. Okay, that's... Oh, we forgot the 10K R16 and the 1K R20. So this is the 10K one, which is R16. Where are you, R16? Up there, good. And R20, the I don't know what you're for resistor. But I'll put you in anyway, because maybe you are good for something, really. Just seems to be a 1K resistor across the VCC and ground lines. And I don't know what it's there for. Just to waste a bit of power, maybe? Don't know. Maybe I have to look at the schematic a bit better. Okay, that's section 411 and 412 done. Now let's move on to section 413, which is the supercap circuit. Now this guy has an arrow on it, and it has to match up with the arrow on the board. I don't know if you can see that there. There's a little arrow, and there's a little arrow on that, and we'll pop that in there and be happy about it. That's a 0.22 farad supercapacitor. Then we have to put in, that was C6, then we should find a C5 somewhere. I would imagine it to be quite close. Oh, C7, not C5, C7, over here. And then we just pop the header in, which is used for unlinking the supercapacitor from the rest of the circuit. In the case that you need to reset quickly, you can do it by taking off this header. Okay, that's standing up straight. Okie doke, let's pop the header on. That's 413 done. So it says here, I should mention this, C6 and the two-way jumper need to be soldered on the bottom if you're using the stainless steel case. I'm not using the stainless steel case. I'm not going to use any case at all, or a plastic case, or a case I make myself. Okay, we're good. That's it, we're done. Section 413 finished. So now we're going to get on with the build of section 414. And the things we're going to need for that are D4 and D6. There's a yellow LEDs, so D4, D6. D5, which is a green one, which will go there. the 4 buttons, so which go along 1, 2, 3, 4, and 2 3.5mm jack sockets. So there's a note in the manual here, depending on which case you're going to use, certain parts go on the top or the bottom. So I am going to build as if we're building for a Visio and Prisma case. So all of these components go on the top side, so they'll all go along here. If I was using the stainless steel case, which I'm not, you would go onto the bottom here. But I'm going to put them all on the top. So the LED has one longer lead and one shorter lead. And the shorter lead has little flat on it. But the longer lead is the one that goes into the plus hole. Often I bend these so they're facing out the back, but I think this time I'm going to just pop them straight in like that. Or shall I bend them? No, I'm going to form the leads. So D4 and D6, D4 and D6, longer lead into the plus hole, and I'm just going to put my long nose pliers in there and form the pins. So here goes D6. Okay. Now, do I like that? That makes the whole board bigger. No, I don't like that. No, I'm going to stand them up straight. So I'm going to mount them a little bit proud of the board. So let me just solder that properly, the other lead. No, I prefer to have them standing up like this. So longer pin into the plus hole. Longer pin into the plus hole. Make sure they're standing more or less the same height off the board. And D5, the green chap, and again, longer lead into the plus hole. Okey-doke. Then the buttons. We pop these all in along the back here. Yeah, they stick out as well. So much for me planning not to have anything sticking out the back. Alright, so be it. That one didn't take. Let me try that again. Okay. They seem to be in well. So let me solder the other pins. The other mounting pin and the two electrical pins. The other mounting pin and the two electrical pins. The other mounting pin and the two electrical pins. And you guessed it, the mounting pin and the two electrical pins. So the two 3.5 inch jacks. So I'm going to do this by wetting one of the pads. In fact, I think I can probably just do this directly like this. Okay, so I'm just soldering one of the pads first and make sure they align properly, and the others will follow directly. This is a bit fiddly, this stuff. With these, it's important to get the heat onto the pads. It's so easy that the heat only goes into the pin of the socket and not onto the pad itself. And if you don't do that, then it won't take. Okay, that's 414 done. Then we go on to 415, which is the buzzer. And that's very simple. This section isn't going to take very long. We'll pop the buzzer in its hole, give it some tape, and we're good. That's 415 done. The next